The first machine learning process that we have to do is called dividing the data set into training set and test set. Okay. What is divided into training set and test set? Now, let's say if you have to test someone, let's say you have, you are a teacher and I have to test. Why is it not getting shared? And I have to test, how well you have done. So what will I do? I will teach something in the class, right? And in the exam, I will ask something related to. I cannot ask you same questions, right? Whatever I teach in the class, I can't ask you same questions to test you. I have to ask something different, something other than what is taught, but something on the same lines, right? I can't teach you multiplication and ask you division. So I have to ask you division only, multiplication only, because but not the same question. So to know how well your machine learning model has performed, okay, we need to divide the data set into training set and test set. We need to divide the data set into training set and test set. I don't know why this. I clicked on share screen, but I don't see anything happening here. Okay, so so I'm taking out the other. Yeah, this is what we had done. Okay. Right? Yeah. So next step, as I said, is to take. Now, which algorithm model should we run? Which algorithm model should we run? Okay. Mostly, okay, we talk about what is called as. Okay. Okay, you have regression, classification, and what is the third one? Clustering. This is what we did day one when we were just started. Okay. So once your data set is ready, next we need to understand which algorithm should we run, which model should we run. Okay, so these are different families. Okay, what you are seeing here, these are families of algorithm. Algorithm. Okay, so regression is all about working with past data, and predicting future. Classification is also working on past data and predicting future. Clustering is different than these two because clustering we don't have Y concept. Okay, so we don't predict or we don't work on past data. You will have X, but in clustering we don't have Y. Why we need to plan? For example, I always give this example. So in a room filled with, let's say, different fruits. Okay, so let's say you have apple, banana, cherry, and mango. Okay, I'll ask you to segregate them. You can segregate them, right? You can segregate all fruits together, all apples together, or bananas together, or cherries together, mangoes together. You can do that easily, isn't it? Now let's say I give you 4 different fruit, okay, and you don't know the name. Okay, you don't know the names of those fruits. Can you still segregate them? Okay, I given you same set of fruits, but you don't know which fruit are those. Can you segregate them?
Shape, yes.
Answer is yes, you can. Okay, because all of them will have different shape, size, color, right? Based on that, you can segregate them. So take same example, apple, banana, cherry, and mango. If you didn't know the names, still you could segregate them. So this Y is the name, right? Y is like that label. We call that label. Okay, why it's called label? So when you have multiple X, right? Yesterday we have seen uh, R&D spend, marketing spend, all those spend, and then state. Based on that, we are giving a label Y. Okay, so much is the profit. If these are the input, this is the profit. Okay, so in case of apple and fruit, okay, size, color, shape, these are the input. Then this is the name. So okay, when you have Y clearly given in the data set, we will either perform regression or classification. Okay, this is how you identify which algorithm to predict, which algorithm to run. Okay, we'll get into each of these in detail after we have done the statistics, but let's understand this. Okay, so when you have Y, then it is either your regression or classification problem. Okay, we have Y, so we know, okay, we have some data, we know some input, and we know the output, we know the label. That's why classification also called as labeled data. Okay, and clustering we call it unlabeled data. You will not have Y, you only have series of X. So in this case, we have series of X and Y. We have corresponding Y also. So definitely this problem does not belong to clustering type. Okay, this problem does not belong to clustering. We either have to perform regression or classification. Okay, second thing, when you don't have Y, then you can create your own Y. Okay, you can create your own Y, and we'll do that when we go there. Now, coming to, okay, when you have Y, it is called supervised learning. Supervised learning. Supervised learning, you have regression, you have classification. In unsupervised learning, you have only clustering. Okay. So unsupervised learning is where there is no one to tell you the answer. There is no one to tell you this is apple, this is banana. Okay. In supervised learning, as the name says, supervised learning, somebody has told you this is apple, banana. Okay. So you know the output. Okay, and you don't know the output in unsupervised learning. You don't know what it is. You have all the information, but you don't know what it is. So in that case, you can make your own assumptions. Okay, you can make your own assumptions, right? Okay. Coming to supervised learning, and most of the problems will be from supervised learning only. Okay, most of the problem. Okay, and you will be working with supervised most of the chances of getting into project. Okay, is high on supervised learning. Now, in supervised learning, we have two families of algorithms. Okay, regression and classification. When to use regression and when to use classification. When your Y is a numeric value, continuous numeric value, when Y is, it does not matter on X. X can have both numeric and categorical. Okay, in our example, we have both numeric and categorical X. But what is Y? That will dictate which algorithm to select. So when Y is numeric, okay, and doesn't depend on X type. And when your Y is categorical, okay, then we use classification. Our example that we did yesterday, is it numeric or categorical? What is the Y? Do you remember?
Numerical, sir. Profit.
Do you remember?
Sir?
What was the Y?
Numeric, sir. Profit.
Profit, isn't it? Yes.
Yes, sir.
So profit was the Y that we're looking at, numerical, correct? So
yes.
Which algorithm should we apply?
Regression.
Regression. Okay. If the output was something like, will the person buy or not? Yes, no type.
Then classification.
Right? So we'll have to use classification. Okay. So this is how you have to first look at whether it is a supervised problem or unsupervised problem. Do they have Y or not? If they have Y, it is supervised problem. If they don't have Y, it is unsupervised problem. Okay, so that's the first question that you have to ask yourself: supervised or non-supervised, X or Y. Okay. Second thing, if it is supervised, Y is there, then what is the nature of Y? Okay. Second, say Y column is present, and here Y column is not present. Okay. Is not present. Okay. So column Y is present, and this is a regression and classification. These are the two decisions you have to make. Okay. How do you know that we have to apply machine learning algorithm? See, later you'll talk about supervised, unsupervised. How do you know that it is a machine learning problem? If they ask you to predict what will be my sales next month,
Yeah, yes, sir.
what was my sales last month is not machine learning problem. What will be my sales next month? What
Future
will be-
prediction, yes.
What will be my sales tomorrow is machine learning problem. What was my sales yesterday is not machine learning. That is analytics, simple analytics. Okay, who was my best salesman for last year? Is your simple analytics problem. Who will be my best salesman for this year? Is your machine learning problem. Now tell me, who will be my best salesman for this year? Is it regression or classification or clustering problem?
Classification.
Why?
We need output, best salesman, and name. So categorical.
Right? So you have a salesman. You know who are your salesmen. Let's say you might have 50 salesmen in your company, right? So Y is given because we are trying to predict Y only, right? Who is your best salesman? Okay, so Y is present. So definitely this is not your unsupervised problem. This is supervised problem. Okay, so unsupervised problem. And the answer is not about numeric. Now, if I'm not asking how much sales will I make, numeric, how much sales? I'm talking about who among 1 to 50. So the answer will be 1 among 50 only, not anybody else, not 49.5 or 38.5 or 52. It has to be 1 among those 50 only, isn't it? So this is a classification problem. Okay, supervised because we know that it's going to be one of the 50 people. Okay, and then who's among the 50. Okay, it's among the one among the 50. So it is definitely categorical value. So Y is present and Y is categorical. Okay. Now, spam, say spam detection, machine learning algorithm. Which one of these three will be? Tell me.
Spam detection, sir.
Yes. So your email, okay, will detect spam, right?
Yeah.
Okay. So email will detect spam. So when you log into your
Classification. Classifications.
Is it classification?
Yes, sir. Output is spam. And obviously text is a mail, so categorical.
What about others? Are they sleeping or not? They are not able to hear me. Classification of spam. What kind of problem? You have three options only, right? Regression, classification, clustering. That's all. So machine learning is all about these three applications, so three family only. Okay.
Yeah.
Yes, yes, binary classification problem.
Yes, Karthik.
It's binary classification problem.
Binary classification. What is binary mean? See, you try to Google where it matters. Where in interview, if you can Google, that's great. Cheating should be done in the exam. Then only you get marks. What's the point of doing cheating in the class? Right?
Yes, sir, you're right, sir.
Cheating in the exam, you get marks. In the class, if you're cheating, you won't get anything. Correct? So here,
Yes,
I want
sir.
you to think. Okay, I want you to think. Okay, you should You should do cheating where it matters. Okay, not where it doesn't matter. Okay. Okay. So the point is, okay, here you have X and you have Y. What is Y? Y in this case could be, okay. Now, what Google is doing is not binary classification. Okay. Binary means output Y has only two values. Okay. Yes, no. Okay. So maybe if you are talking about uh, uh, Rediff will have inbox and spam. So that is a binary. Okay. When email comes, they look at the characteristics and they classify. So here you have Y values, right? What are the values? Inbox or spam? Spam or not spam? Yes or no? Okay. Yes or no? Okay. Yes or no? So it's a two option. Y has, so you have a Y. It's not like you don't have a Y. You have a Y here. Okay. So it is a classification problem. Okay. Okay. Why is that? So it is supervised. And since we know it has to be either, okay, spam or not spam, so we say binary classification. Okay. But in Google, you have inbox, social, promotion, spam, 4 options. So that is more than binary. Okay. But yes, okay, it is a classification problem. Okay. Supervised classification problem. Okay. Great. You know what is recommendation engine? Recommendation algorithm? See, when you log into your Amazon.com or Amazon.in, okay, it will give you prediction that people like you have also bought this app, this product.
Yeah.
Okay, what is that? Is that classification, regression, clustering? People like you have also bought. Okay, you may be interested in. Okay, so in this case, okay, if you see, okay, you don't have Y. We are not labeling it. We are not saying, spam, not spam, yes, no, north, south, east, west, no. Okay, here there is no value for Y. Okay, so this is like segregating fruits without knowing their names. We don't know why, still we have to segregate. So on what basis? On the characteristics. So what are the characteristics for this problem? So they will look at what kind of problem or no kind of product you buy. Are you buying only electronics? Are you buying electronics and grocery? Are you buying only dresses? Right? That is one kind of X. Second kind of X could be how much money are you spending? Okay, are you spending below 1,000 rupees per month or 1,000 to 5,000 per month, 5,000 above per month? Okay, these are the characteristics of a shopper. I want to classify shopper. Into groups. Okay, just into groups. That's it. And it doesn't matter what group name you give. So it can be possible that all our shopping behavior is similar. So Amazon will group all of us together. Okay, so let's say we buy same kind of product from Amazon. We spend same amount on Amazon. We buy during, let's say, festivals. We always buy during festivals. Let's all of us do that. So these are characteristics. Looking at the characteristics, okay, Amazon will create a cluster and call it as group ABC, and all of us will part of that group. So when we are part of that group, after clustering, whatever I buy will be shown to all of you as a recommendation. Whatever you buy will be shown to all of us as a recommendation. Why? Because we belong to same group. Okay, and doesn't matter what we call this group as. Doesn't matter what we call this group as. Now, in the previous example, the spam example, let's say it is able to classify, but if Amazon doesn't name it as spam, then what will happen? All the spam will go to inbox, all the inbox will go to spam. Not right. This is not correct. Amazon will say, Google will say Gmail will say, see, I'm classifying correctly. All these are one group, but you have labeled them as spam. How can you put non-spam there? So it is important, right? See, you can collect all banana, but put it under apple tag. Incorrect, right? So when you have a label, it has to go into label only, even though you have done a great job of finding all bananas together, but you have to put it in the banana bag only. That is classification. And you don't have bag, you can put it anywhere. Okay? Because you don't know the names, you don't know, your bag does not have that label. Okay, label is not required. Recommendation label is not required. You just need to know which group you belong to. Okay, it just needs to know which group you belong to. Doesn't matter. Okay, what is the label? Label can be A, B, C, D, X, Y, Z, 1, 2, 3, 4, doesn't matter. But in spam, label matters. Spam and non-spam matters because we go by how many times do you see spam in a month? Probably one, or probably even, you may not even see spam in a month. But inbox, probably we see almost like 3-4 times every day. Right? So that's why label is important in that case, but in case of recommendation, label is not important. We have to apply clustering example. That's a clustering problem. Okay. Since Y is not there in clustering, we will not talk about clustering for now. Okay, we will focus on classification and regression. Okay, we'll talk about clustering later. First, we'll focus on this. Now, regression is one single name, but it has multiple algorithms. That's why, even if you see that, okay, if only 3 things are there, but why is it complex? Why we talk about machine learning and we spend 3-4 months to learn? Okay, it's because it is just regression and classification and clustering, but regression will have 50s and hundreds of algorithms. Classification has hundreds of algorithms. Even clustering has hundreds of algorithms. Okay, more we learn, more experienced you are. Okay, so it is about learning as many algorithms as you can learn. Okay, so
where can we find this algorithm, sir?
You can find it in my book on Kaggle.
Okay, sir.
Okay, you just type regression algorithms. Okay, you get many. Okay, so ideally, you start with one algorithm, master it. Okay, understand what are different components, different parameters. Okay, if you change one parameter, then what happens to other parameter? Okay, if you change one thing, what happens to the answer? Okay,
sir.
Okay, so that's the important. So learn one algorithm, master it, then take next one, then next one, then next one. Okay. Each algorithm has its own characteristics. So when you are playing with the data set, looking at the data set, you should know which one not to include and which one to include. So now we know which is regression problem. But regression, which regression to take and which regression not to use here. Okay. So that's also one of the important discussions we'll do. Okay. Only get into that, you will know. Okay. We still have 1 month to go. Okay. So where was I? Okay, regression. Now, the first thing that we have discussed so far, pre-processing. Okay, and pre-processing, I told you, okay, there are more things to it. We'll do as and when required. Okay, we haven't done min-max value. Okay, we only looked at categorical, but we have not seen areas where the X are, we discussed, right, age versus salary. Okay, so all the X's should be in same order or similar range. You cannot have 2-digit and 7-digit. Okay, so we have to do minimization there. We'll do that. Okay, so there are many steps that you perform. So machine learning algorithms, note down, these are the steps and try to learn as much as you can about these steps. We're going to do in our course, but also when you read it as these individual topics. First step, pre-processing the data set and make it ready for modeling. Okay, write it down. Okay, let me also write it down. Different phases of machine learning models. Okay, first is different phases of machine learning modeling. Step 1, pre-processing the data set and making it ready for modeling. Okay, so this involves missing values, categorical values, column values. Sometimes we might have unbalanced data set, balanced and unbalanced data set. Okay, how do you manage balanced and unbalanced data set? All those things we'll talk about one by one, slowly. Then second thing is choosing the right model. Okay, this is the easiest of all. You know, 3 options: regression, or classification, or clustering. This is the most easiest. This is the easiest of all. Then breaking the data set into training and test model, test data. Okay, so what does that mean? This is also, and this is one line. Okay, this is really not okay, this is really, I mean, this you can include as part of 2A only. It's not as significant to call it as different set. You call it as 2A or 2B or whatever, part of the second step only. Okay, you're choosing the right model. Okay, so here, see, when I have to test you, I want to know which among you is intelligent, most intelligent. Okay, what will I do? I will conduct the exam, right? The test that the school and college conduct, universities boards conduct, is to know how much every student, because you cannot treat every student as same, right? There has to be some competition among the students. Okay. Similarly, when you talk about regression we know, but what in regression is it? Algorithm 1 or algorithm 2 or algorithm 3 or 4 or 100? Which algorithm is best in regression for specific data set? Okay. Okay, so it doesn't mean that if you take test once, then you never take test again. On that day, on that particular subject, who is the best student, right? The person who tops in Telugu did not top in English, did not top in science, right? For every topic, every year. So every data set, even though all of them are related to regression, but not same algorithm will be better. So we need to divide the data set into training and test. It's like this. See, if I have to judge you, I cannot ask you a question for which I don't know the answer. Correct? If I don't know the answer, how can I test you? Because if I ask you the question which I don't know the answer, I will not be able to judge you on the answer that you give me. You give me the answer, but I don't know if the answer is correct or not. So whatever you know, so these are the data set, right? So in this case, this is what we will talk about now, okay? So if you have 100 data set, I am going to put 20% aside, 20 rows aside. And I'm going to expose only 80% to the model, to the algorithm. I'm saying algorithm A, okay, if I know 100%, okay, if I know 100%, okay, I mean, say 100% of little bit. Okay? I'm not saying that I know 100% of machine learning, but let's say I know 10% of machine learning. Let's say I know 10% of machine learning. So what I'll do is I will teach you 80% in the class. 20% I will not teach you. Why? Because that 20% I want to test whether you know or not. Did you understand the logic?
Yes, sir.
I will, let's say if I know 10 things in machine learning, I will tell you 8 things. And these 2 things I'll keep aside to test you, whether you have understood the 8 things or not. How will I know whether you understood 8 things or not? I will give you these 2 things and I'll ask you to apply your knowledge. And I will see how well you're applying your knowledge on these 2 things. If I tell you everything, then there is no point of asking the questions, right? So that's why, when teacher which gives all questions, exam questions, is not a good teacher, right? Teacher should explain you the concept and ask you different questions related to the same concept. So here, these are the data sets, right? So these are the same data set, right? I'm not going to test you on different data set. What I will do, I will hide 20%, 25%, 30%. Generally, 20 to 30% is recommended. So you hide 20% or 30% or 25% of data from the model, from the algorithm. Okay, which algorithm? The regression algorithm, right? So we know it is regression, but in regression you have multiple algorithms, right? You have many algorithms. So we will have to run all the algorithms. We'll have to run all the algorithms one by one. So you are running the algorithm on 80% of the data, 20% you are hiding. Okay, you are training. So 2 parts to it. Machine learning, when you say run the machine learning model, this is also the easiest part. Run the model is choosing the algo and running. Running will have 2 parts. Training the algorithm and then test it. So this is called run the model is training the algorithm. Okay, and then step number 4 is to test your model. Okay, the most difficult part is this first step. Okay, second most difficult part is your testing. Easiest is running the model. 2 and 3 are the easiest. Okay, we spend more time on making it ready. See, again, bad example, but let's see, you are responsible for conducting an event. Diwali, for example, let's say Diwali festival. More time we spend in before Diwali, right? Cleaning the house, buying crackers, doing this, doing that. You spend so much time in planning and doing this. Okay, Diwali night, what? Half an hour you burst all the crackers. Right? The effort that you're putting on the lights, buying sweets, doing all these things will take you 1 week. And in 1 hour, all crackers, everything is gone. Diwali is over in 1 hour. And then next day again, you have to clean the house. Right? Though we say Diwali, the actual time that we spend on Diwali is 1 hour. But we spend 7 days before Diwali and maybe 2 days after Diwali. Agreed?
Sir.
Same thing with machine learning model. Preparing for the model is very, very important, very, very critical. One step.
Sir, can you
Sorry?
please tell me that example? Can you please tell me the example of Diwali again?
The Diwali example again. Okay, this is bad example, but this is how machine learning models are like that. And what I'm saying is, your Diwali that you will spend is only 1 hour or 2 hours Diwali you will spend, isn't it? 6 o'clock,
Yes.
7 o'clock you switch on the lights, maybe burst some crackers, sweet, 1 hour, 2 hours Diwali is done. But you're preparing for 1 week. You're planning which dress to wear, you will go and buy the crackers, you will go and buy the lights, you will put the lights. You're spending 1 week to plan and prepare for Diwali.
Yes, sir.
Right? But Diwali, 2 hours gone. Diwali, which is one of the biggest festival, is gone in 2 hours. And the next day again, you are spending time to clean the house. Okay, oil will be spilled. Okay, crackers is all over the place. Paper is all over the place. You have to remove the lights. All these things again, you have to spend 1 day.
Yes.
Right? So same thing with model. Okay, pre-processing, making your model ready, making the data set ready. will be 70% of your effort, or maybe 60% of your effort. 10% is running the model, because running the model is nothing. You just, okay, select, regression, list of 100 algorithms, you already have it. You start running all this model one by one. Then pre-processing, you have run the model. Now, which parameter to tune? Okay, which parameter to tune? How to? So here, when I say test the algorithm, it is parameter tuning. Okay, is the most critical thing, right? Now, 1 and 2, which is most critical, cannot be taught in the class. You can only learn by practicing. I can teach you different algorithms. Okay, these are the algorithms, these are the parameters, this is how it model works. But your effort, that's where the people, the experience. Now, if you talk about machine learning, a fresher is also learning this course, and experienced person is also learning it. The difference is how you implement it. Okay, initially when you go as a fresher, right, somebody will tell you, run this model, run that model, do this, do that. You will be thinking, I am doing all the hard work, he's just telling me do this, do that. No, running hard work, you are not doing. Computer is doing the hard work. You are only selecting the parameters and giving it to the algorithm. Okay, no, okay, forget about all this. What I'm trying to tell you is, pre-processing step is very critical, and your post-processing, okay, you can call it post-processing, is also very critical. Which parameters? Okay, if we talk about SVM, what are the different parameters that we can change? Okay, what happens when we change this parameter? Okay, what happens to the, here now you have terms called accuracy. When you test the model, you are actually testing the accuracy of the model, how well your model has predicted. Okay, now if you see all this data, what we have here, we have Y and we have X, correct? So we have the answer. So you are training the model, okay, and you hide some rows from it and you pass the others for training. And then on the sum that you have hidden on the test side, you don't give Y, you only give X. And you're telling to the model, now that you have learned, okay, you have been trained, you have learned, now predict for these many rows. So model will predict the Y. You take the Y and compare with the actual Y and see how much is the difference between them. That is the accuracy. Understood? So if you have 100 rows, you are giving 80 rows for the model to learn, and the rest 20, you are hiding the Y, you are only giving 20 access to the model and saying, now that you have learned on 80 rows, please predict these 20 rows for me. And the model will predict the 20 output for the 20. You compare the 20 and you see the accuracy. That is your accuracy. Okay, accuracy and error, they are opposite, right? 100 minus error is accuracy, 100 minus accuracy is error. If I say accuracy is 90%, that means error is 10%, isn't it? So you'll calculate the error. Now, if you are working with model ABC, right? No, sorry, not model, you can say algorithm, right? If you work with first model, which is algorithm ABC, you get accuracy of, let's say, 87%. Is it the best accuracy that you can get from A? Is it the best accuracy that you can get from model A or algorithm A? You have to, that's why you have to tune the parameters and see how can we get best model. Okay, so the best model is, okay, we don't know yet. We have only tested algorithm 1, A. And the best accuracy that it can give is 87%. Now you test algorithm B and get the best accuracy. Model C, D, E, F, you run all the 100 models and you see the accuracy percentage of all the 100 models. And model, let's say F has given 93%, that is the highest. So model F is the most preferred model for this kind of problem.
Sir, so each time we'll be running all the models and checking.
Yes.
Okay.
Okay.
That is what we'll be paid for.
Yes. No, so in fact, you will be more paid if you know that before running that this model will not work.
Okay. That comes with experience.
That comes with experience. So when you look at the data set and you know what kind of what is the relationship between the model. So how does model work? What is the relationship? Okay, if you know that, okay, you will be paid higher if you know which model will not work. Okay. Okay, so that is also the case. But if you don't know, you have to run it.
Okay.
That's why when you read more about the algorithms, okay, you take one algorithm, read about it, what it is, how it is used, when it is used, when it is not used, etc. Now, see, example is now if you are predicting car sales versus atta sale, right? It's totally different. Atta sales is probably more easier to predict. Whether economic goes down or up, atta rice sales will be more or less constant only, right? You don't eat more when economic goes up, and we don't it goes down. So your price sale will probably be almost constant. What happens to the economy? But your cars will be a lot of fluctuation.
Yes.
Right? Credit goes down, probably cars will go down. Goes up, okay, salary is increasing, everything high, cars will go up. Okay, so the data is different. Okay, if data is different, algorithm will also has to be different. You cannot use same logic that you're applying over atta or rice sales over car sales. So algorithms which might work well for predicting rice sales will definitely not work well for predicting car sales. Right? So that comes with experience. Oh, this handles more fluctuation. So probably this is not good for this kind of data. Right? And in percentage, okay. So predicting car sales like 95% is great, but predicting atta sales of 95% is probably not good. You have to predict up to 98, 97, 99%.
Yeah.
So it depends on the data set as well. Okay, so these are the steps, and today again we'll do a little bit of it, and tomorrow we will finish this example of running with one model only. Okay, so as I said, first that we do is we will break this data set into training and test. Training is what we will train the model, and test is what we will test the model once it is done. So did you understand, everyone? Any questions here so far? So pre-processing, again, a lot of steps are there. I'm just showing you one particular step. Okay. So our X is now pre-processed. Okay. So before we run the model, we have to split into training set and test set. Okay. So how do you split? We have to use sklearn from sklearn dot for model selection. Okay. Model selection. Okay. Import train test split. Train test split. Okay. So now we will split our xy. Okay. So this is the function train test split. Okay. And here I'm giving first x, then our y. Okay. And then what is the test size you want to give? So you want to give 20%, 25%, 30%, 50%. You can decide. Okay. It's called test underscore size, and you can define in float value. When I say 0.2, that means I want 20% of data. So see, when you have very less data, you want more data to be given for training. So here we have only 100,000, I'm selecting 20%. If it was 10,000, 15,000, probably I would have selected 25% or 30%. Okay, there is no hard and fast rule. Okay, so this function is ready. This function is going to give us 4 different values, and we have to save those 4 values. What is the first value? First value is called xtrain. So it will divide into x and y. X is divided into two parts, and y is also divided into 2 parts. X, since we gave x here, output first will be xtrain. That means when you say train, that means you get 80% of the data. See, it's up to us what we call it, as train or test, we call it, it's up to us. So when I say, train, that means this will have 80% of the rows of x. That is followed by your x test. X test means this will have 20% of the x value. Okay, then you have y train. So this will have 80% of the y value, and that 80% and x train and y train, they will have the similar data sets. The index will be similar for both. Okay, it will not take any 80% there, any 80%. The index will put them together. Okay, that's why we are doing together. We are not doing x together, separately, y separately. We could have done x separately, y separately, but the problem is we also want x and y to be linked. Answer key, question and answer key, right? You give the question, answer key should match the question number, isn't it? That matching is done using index, and that's why we are putting it together. So x test, x train, x test, y train, and then you have y test. Right? Now you decide which model to run. I'm going to run multiple regression. I'm not going to talk about algorithm today. We'll talk about it tomorrow. So selection of algorithm. So by now we know we have to run regression, but we don't know which model in regression. So I'm going to call our first model. Okay, so this is in from sklearn dot linear model. Linear model has all the linear models. Okay, and one of the linear model is called linear regression. Linear regression. I'm going to run linear regression. The first thing I'm going to call linear model object. Linear model, linear regression, whatever. Okay, this is your linear regression model. So we have chosen algorithm 1, which is linear model. I have created an object called LM, and this LM is now ready to work with our data set. So first thing is training. I can't ask you question without teaching the concept, right? For all 1 year you learn to write that 1-day exam, right? So same thing, 80% we are training to write the exam on the 20%. Okay, so how do you train the model? You say this LM dot fit. Fit is training the model. So how do you train? You train on X train and Y train. I'm saying these are the questions and these are the answers. Okay, I'm saying linear model. These are the questions, X train is the questions, and Y train is the output answer. You learn from it. Okay, the pattern we are not telling. We are asking model to learn the pattern. Now the training is done. The next step is we will not show Y test. We will give X train and will tell, please predict it for me. So I'm going to say Y pred. This is the predicted values. Okay, these are the predicted values. And I'm not saying, okay, linear model, please predict it for me. So I'm going to say lm dot predict. Okay, and we pass X test. So Y pred is the values. X test, did I not put X test here? Okay. Okay. So now X test is passed and Y pred is the values that is predicted by the model. Now to know how well we have done, we have to combine them, isn't it? So let's create a data dictionary, okay? Or let's create a data frame with 2 columns, okay? 2 headers and values here. So I'm going to call something like result df equal to. Am I using pandas? Of course, I'll be using, right? I'm reading the data set. Okay, so I'm going to say pd dot data frame. I'm converting to data frame. Okay, data frame f is capital. Okay, and now I'm passing this dictionary value here. Okay, so key value, key value. Key is actual value. Actual is what? Y test, which we have got it from here, which we have not given it to the data. Now, predicted. Our model has predicted these values. So, what's that?
Y predict.
Y predict. Okay. So now this is ready. If you want to see the output, you will say result df. Okay, so result df, first it will have the actual, which is actual value, and predicted, which will have the predicted value. Now you see. Okay, so I think it has only 50, right? That's why 20 gave us only 10 rows. Okay, so it has 50 rows. So 20% gave us 10 rows. So this is the actual value. So actual value, the profit predicted is 103K, and it is saying 100K. 126, 117, 166, 171. So this is the actual value and this is the predicted value. Okay. Now,
In sixth one, there is lot variation, sir.
Yes.
14681 50561.
5, no? 5 digits, both are 5 digits, isn't it?
Yes, sir.
But you are saying this 40,000, it is 50,000.
Yeah.
So that's why it's called regression. Okay. What happens? I'll tell you. Okay. So let's say 5,000 years back. 5,000 years back. Okay. And see, the regression concept came from biology only. Regression concept is one of the oldest concepts which we have been learning for last 200, 300 years. Okay. This is not something new. Regression concept is very old concept. Now that we have computers and machine learning and this, we are implementing it. But biologists have been using this concept for many years and centuries, more than centuries. See, the concept here is it's called regression, not progression. Okay, simple example. Okay, so 1,000 years back, okay, not 1,000 years back. Let's say if there is a person who is 7 feet height. So the children of that person, do you expect that person to be taller or shorter? Taller, right? So if the person is 7,000 feet, you expect that person's sons and daughter to also be taller, right? So
yes, sir.
So if you follow the same logic, 1,000 years back, definitely there would have been someone with 7 feet height.
Yeah.
There would have been at least 1,000 people. Okay. Now they will have children taller than them. They would have had 7 feet 1 inch. Their son would be 7 feet 2 inch. So going by that logic, we would have somebody with 10 feet today.
Yeah.
But do we have anybody with 10 feet today?
No.
So the logic is wrong. That's what this is example biologists have said. That's what we call regression. Okay? You take example of Sachin Tendulkar, great player. You expect his son to be even more greater player, right? No. So biology said no. Biology subject says everything is normal, average in this world. Okay? If you are intelligent, if you are Sachin Tendulkar, it is an exception. As nature does not expect everybody to be Sachin Tendulkar. If you have become Sachin Tendulkar, it is an exception. If you are somebody who gets out on zero, that is also an exception. Okay? Your average is going to be average only. Okay? Just because one value is exception doesn't mean that every values will be exception. If you take somebody's cricket, if you watch cricket, right? Cricket's average you take. Okay, why Kohli is going through bad phase now? Why Kohli is not able to score run? This is nature. This is nature. If you score 3 centuries continuously, you will score 10 ducks continuously. Your average is going to be 40 only. Okay, you understand? If your average score is 40, if you score 100 in one match, the next match you will score 0. Now, 2 matches you have to score 0. Okay, then only your average will become 40. Did you understand? So that's what we call regression. Regression means you're coming back to average line. So this could be an exception, very low value. But this, just because we have one low value doesn't mean that our expectation will be low. Just because you failed one paper doesn't mean that you will fail all the papers. Just because you have scored 100 in one paper doesn't mean that you will score 100 in all the papers. Right? So that's the concept here, and very well. Okay, this mathematical model has very well established that fact. Okay, and we'll see tomorrow what is the mathematics behind it. So what it says is, no, we expect it to be average. Just because you failed one paper doesn't mean that you will fail all the papers. Just because you scored 100 doesn't mean that you will score 100 in all the papers. Okay, so it could have been, something 10 times of this also, or maybe 1/10 of this also. But we expect it to be around 50,000. Just because it is 14,000, it could be an exception, rare case. Okay, but still our expectation prediction will not be defeated, or will not be, then you become biased. Okay, if you say Sachin Sir will be a better player, you're becoming biased. You're becoming biased by one person. You have to look at entire data to predict something. You should not be influenced by one value. Okay, so we have a very important concept called as bias and variance. Okay, bias exists. If I had given only one row, if I give only Sachin's example, then every player will be credited as a great batsman. No, you have to give all the data. Then only machine will say, okay, Sachin is an exception, but this is what it should be. Okay, so your data can have bias and can have variance. We'll talk about it, not now, probably after 2-3 weeks we'll talk about it. Very important concept. Okay, when you are learning, when we are doing performing machine learning, we just don't go by this output. That's why I said, right, most important difficult part is pre-processing, and second most difficult part is post-processing. Okay, this is not the answer. This is the simplest. What I have done today is the simplest and the easiest of the thing, which will take most of our time, unfortunately, because we have to learn all these things. But what is important, I can't teach you. You have to understand it. Okay, so we will, we'll take a lot of examples to understand what it is. Okay, so this is the model. Okay, the model is done. Okay, we have seen the output. Now we have to make the prediction. This is the last step for today. We'll make the prediction. How do you make the prediction? Okay, so we have to find. So again, I have discussed this before, right? When you have, this is also called as expected value. Okay, this is also called as expected value. This is what we expect, correct? In statistics, expected value is same as mean. Okay, now here, if you normal statistics, we would have taken the mean of this as expected. But since it's a mathematical model, okay, each row has a different expected value. Okay, let's take it this way. You have 2 schools. Okay, let's say you have, Pujita, of course you have, children. I have children. Now let's say we have to decide which school is good for him or her, and you have 2 schools to compare. Okay, you have option either this or that. How will you decide which school to put your kid in?
It depends on many factors, not just one factor.
I'm asking you, you tell me. Oh.
One is distance point of view, sir,
Yeah?
and distance point of view,
No,
and
so distance, both are equidistance. That's why, see, there are hundreds of schools, right? Based on
okay.
distance, there are 2 schools. Then next,
Curriculum based, like CBSE or ICSE.
CBSE school.
There comes many factors, sir, and financial point of view also.
I'm not asking others. Okay? You tell me all the factors. See, all the factors is what will make your program correct. You cannot be biased by one factor. Just because
Okay.
there is a factor is
Whether the school is providing, yeah, whether the school is providing school transport or not, or I have to go for
both are providing school transport. Next.
fees, sir, fees.
Both are taking same fees. Factors which can be, and see, what I'm telling you is not unbelievable, right? Since they are in same level, okay, the fees has to be same. Otherwise, people will not go with the, so they are same distance from your house. They both provide transport. Both have CBSE syllabus. Both take same fees.
Analysis, result, like considering the previous data, if everything is same,
What
we'll
data
consider
you will get?
so and so year, what is the pass percentage?
Pass percentage. Let's say even
Yes.
pass percentage is same.
Chit le lo.
Okay. So see one more thing. See, pass percentage you are attributing to school. See, fees
Okay.
you are attributing to school is fine. Transport is a student, college school responsibility. But pass percentage, is it school's responsibility? No, right? See,
Yeah. Yes, sir.
generally, what we do is when you don't know machine learning, we would take the average. Okay, pass percentage, average. But that's not the factor. You have to see how much hours students are, putting into studies. If the students are not putting effort into studies and their marks is low, you cannot attribute to the school. Okay. Now, when you take a student, and a purpose I'm taking because see, fees, transport, these are one-time decision and they will have it. But when you go to student thing, how much marks the student have scored depends upon the number of hours. The first example, very first that we discussed about. Okay. Of course, one factor is how good is your teacher. Second factor is how much effort the students are also putting in. Right? Now, let's say there's a school where,
How can we, you have said 2 factors, no, sir. Like how good the teacher is and
that's
how.
what I'm saying.
Yeah.
You have to look at that way. See, you cannot look at average. Okay, now if you talk about IIT versus an engineering college, or IIT versus our Amirpet, let's say.
Okay.
Now, IIT has already taken the cream student.
Yeah.
India's best students are there in IIT. Can you compare the salary obtained by IIT students versus the student of Amirpet?
No.
Not fair to compare, isn't it?
Yes.
IIT have already taken the best student of the country.
Okay.
Okay? If somebody is getting 5 lakh per annum from Amirpet, it is equivalent of getting probably 40 lakhs or 30 lakhs from IIT. You agree or not?
Yes, sir.
Right? So how can you compare? You cannot compare. So that's what I'm saying. Okay, IIT is better. Of course, IIT is best, but you can't get into IIT. They have limited seats. The point I'm trying to make is the effort versus the output. Okay, how much effort you are putting and what is the output? So we tend to take average pass percentage, average marks obtained by the student. Okay? Those students, they were not studying. Teacher made effort to make them at least pass. Second school, students are very studious. Teacher was not giving any attention. They scored 60. Studious students scored 60 is probably not as good as this dumb student scoring 50.
Understood, sir.
right? So you
Yeah,
would
but
prefer
how will we come to know that?
data. You need data. How can you do without data? That's what I'm talking about. You need data. You need to go and talk to the students. How many hours did you study? What did they
Okay.
do? Simply
Okay.
looking at the past percentage, you cannot decide which is the good student. You have to go and talk to the student. Okay, how much hours did you study? How good is your teacher? Did teacher help you or not? If they say teacher helped me, teacher is very good. Okay, still they got 50. Probably, they did not. Their students were not serious. Okay, or
Okay.
maybe they did not have enough resources at home to study. Maybe
Yes, many factors.
many factors, right? So the
Yep.
point I'm trying to make here is before learning machine learning, that was the only thing. Okay, how good is your process? If I give you this data set, same data set, the one that we're working, what will be the sales? What you will do, you will take all the y, you will take the average of all the y and say this is the answer. No, that's not right. You have to find similar values and then you find the answer. Simple example is, okay, if there's an Indian player, okay, let's say that player is going to make debut in Asia Cup and he's an opener. So if you have to predict the marks, if you have to predict the score that the fellow will score, okay, what will you consider? Tell me. Asia Cup, okay, there's one player from India making a debut, and you want to predict how much score that fellow is going to make. What factors are you going to compare? So if you do not understand about data, what will you do is you will go and you take the average of all the Indian players. You will take the average of Kohli also and take the average of who's batting at 11th position. Kuldeep Yadav also. Okay?
But how is that justified, sir?
This is just, I'm telling you, this is why it is justified. You cannot compare, okay, an opener with batting at 11th position. If you want to predict the mark score that fellow will score, you have to look at all the openers and how much they have scored in their first match. Average of that will be the average that you'll predict for this guy.
Okay.
That's why I'm saying the post-processing is important. Running mathematical model is easy. Okay, you will take X and Y and you will run it. But what is your X? You cannot compare Kuldeep Yadav, right? Or who else? Say Mohammad Shami, if you want to predict their opener score. You cannot compare Kohli and Rohit if you want to compare the debutants' scores. Right? You have to look at all the debutant batting at position number 1, and it was a 50 overs match. You compare 50 overs match only. You don't take test match or T20 matches. Understood what I'm trying to say? So
Yes,
you
sir.
have to have a similar group, and then you take the average of that and you say, this is the score this fellow will do. So the X that you select is important. Okay. That's why when you see this prediction is okay, it's not same prediction for all. What we've been discussing about is we would have got same answer. Predicted would have been same for all values, isn't it? If you look at if you say school A and I say, okay, tell me how much marks the student will get. You will take the average of all the student marks of last year. Last year they got 68%. You will say everybody will get 68%. All the 100 students that are appearing for 10th, you will have predicted 68, 68, 68, 68, 68. Correct? Understand what I'm trying to say? So it's not a single value that you're predicting for the entire group. Okay, last year average marks of 10th class student were 68%. Okay, so then what you're saying, 68% will be scored by everyone. No, not everyone will score 68%. You have to dissect and say this fellow will score above 68, this fellow will score below 68. Maybe your average can be 68 this year also, no doubt about it. But you cannot predict average for everybody. Okay, so before machine learning, this is what we were doing. We were taking the average. Okay, I'm selling my laptop. Who is my customer? Okay, I will look at past data and say male 18-year-old is my customer. but all male 18 years is not a customer. Male 18-year student, male 32 years job, female 27-year job. Okay, so these are your customer. Don't just go by one single average value. All these are average. In a way, these are all average, but this average is calculated based on some limited data, some limited data, which is more relevant for the characteristics X. So characteristics is more important. So far, okay, without machine learning knowledge, we are only looking at Y and we are saying Y. Okay, but now it is not just Y, it is the characteristics. Based on that, we are trying to predict. That's why you have different values for different input values. You don't have same input values. Student who will, okay, who studies for 8 hours per week. There you will say, okay, they will score 75%. Yes, they can score 73. One will score 76. One will score 73. One will score 80 or 68. Okay, because the characteristics are same. We are predicting one value. But you will not predict 60, same marks for who studied for 4 hours also or studied 20 hours also. Okay, so this is what we call as regression. Okay, now how to find the accuracy? Okay, so this is for each one. How to find accuracy? This is the expected, this is predicted. So first step is to calculate MAD, mean absolute deviation. Okay, so we have already discussed, right? So this minus this and take the absolute value. This minus this, absolute value. This minus this, absolute value. This minus this, absolute value. So you find the absolute value of all these 10 rows. You take mean. Mean means average. So one metric is find mean of absolute deviation. That's called MAD, or here it's called MAE, mean absolute error. Okay, but the best option is what we said, the calculating the standard deviation, right? That is called as root mean square. Remember? So first step is to find the difference between them. Then you square it, because that's the best way to convert negative to positive. So A minus B whole square, add them up, okay, and then you divide by n, 10. So that is your variance kind of thing. That is called mean squared error. Mean squared error. Error is what? A minus P. A minus P is error. Square of it, squared error. Take average of it, mean squared error. Each word is telling you what is the formula, right? First is error. Error is A minus P, actual minus predicted. Squared error, square it. Mean squared error, take the mean of that. Okay, that means average of that. Okay, then root mean squared. Why root mean squared? Because we have taken the square before. So bring it back to the same unit, we have to take root, square root. So RMSE is there are multiple other metrics. Okay, we'll talk about it. Like MAE is one, but the most preferred is RMSE. Okay, RMSE. Then we have something called as R square. R square we'll talk tomorrow. Then you have MAE. MAE we know, easy. Now RMSE also it is easy, right? So, but we don't have to manually calculate. We have inbuilt formula which will calculate it for us. So root mean square is directly not available. So we have formula for MSE, mean squared error. Okay, so we have formula for mean squared error. So how to calculate mean squared error? We have from sklearn, we'll import metrics. From sklearn, okay, we will import metrics. Okay, and to find root mean squared error, we have metrics dot. Okay, so let's say root mean, not root, okay, MSE, mean squared error equal to metrics dot. Okay, you will get here root, not root, root is not mean. See, mean absolute error, mean, okay, mean squared error. Okay, all these are metric only, okay, but we'll take mean squared error. Mean squared error will pass the two values. What is the two values? We'll pass our actual, which is y test, and the predicted, which is y pred. Answer that we get, we have to find the root. How to find root? MSE into 0.5, right? This will also give us root, isn't it? So print root mean squared is. So the error of this metric, this algorithm is 10,000. Is it 10,000? Yes. Oh, yeah, it is 10,800, right? 10,000.
Yes,
This is your RMS. So this is the error. Root means square error. Okay. So this is one of the important metric. This tells us this is the error that you get when you run this model. And when you run multiple algorithms, you see which has the lowest RMSE, E for error. So lowest error, right? So you have to find which is the lowest error. That is the preferred algorithm for this data set. Okay, so we'll stop here today. Yeah,
last what you said, sir?
we'll find the lowest RMSE of all the algorithm,
Okay.
and then
Okay.
whichever has the lowest RMSE is your preferred algorithm.
So we have to supply the same data set to different algorithms, and we need to find out RMSE.
Correct. That's what you know for which. See, we have to
Yeah.
find for this data set which is the best, because this is on the past data. We have the answer we know. Okay,
Yeah.
you can only test it on the data set that we know. Right?
Yes.
And
Yes.
then it's like this. It's like in the school, you are tested on the concept which is there in the book. But when you go to the job, right? In the job, okay, you don't have the data set, right? So what they will do is they will pick the student with, who can understand the concept better and put them on the live data. So this is the past data. So from this, I'm going to select the model, which is the best model, and use this model to predict the live data. Because ultimately, I have to predict the live data, right? To predict the live sales, what will happen tomorrow. This is what is already done, happened. Okay, use this to predict for which Y is not there. The actual data, the live data. So our model should tell us which is the best model, what is the best parameter, and that you will deploy at the real problem.
Okay. Got it.
Okay,
Yes, sir.
sure. Any questions before we end?
No, sir.
Okay.
Sir,
So we'll end.
not from this. Actually, we have discussed with CSV formats and all, no, sir. File formats. Now, whatever data we're considering, these are in the
See, that
CSV
is-
format.
Wait. See, what
Yeah.
we did in the file was to just read the file. Okay.
Okay.
For machine learning, we don't need that. That's why I didn't focus much on that.
Okay.
What we need to focus here is reading CSV file using pandas, so that you
Yeah.
get it as a table and row format, not as a text format. There you will get data as a string format.
Yeah.
Tell you that this also exists. We did that,
Okay.
but we have to read as pandas. Read as pandas, you'll get a table and row format. You'll get.
Yeah. Now, suppose I have some data, sir. Suppose I am collecting data of a company, some X company, sales and all. Okay. Now, first I need to prepare it in CSV format, sir.
No, you can connect in any format, right?
Okay.
You can
Just
connect
simply
data
I can create a data frame and perform analysis on that.
Yes. whatever we are doing in data frame. So data frame is important. Before
Okay.
data frame, whatever it is, doesn't matter. Whatever you are getting, you have to convert into data frame.
Okay.
So we are learning based on data frame.
Okay, sir. And second one is we are able to get these graphs, no, sir. Maps as heat map, bar plot, all this. How
Yeah,
to
yeah.
save those graphs, sir?
Okay, we'll do that as well. Just one
Okay.
command we have to say, save
Okay.
as. Okay, we'll do it.
Okay, sir.
Okay.
That's it. Yes, sir.
So there is an option where we save the image, and your image will be saved in a folder.
Okay. So while programming only, it should be done.
Yes, yes.
Okay, sir. Okay. Like now we are just simply getting the graph and we are closing it to get the next graph or output. So before closing it, if we want to save it, that I want to know.
Okay, everyone, take care. Please practice. I'll put this in the same location in maybe an hour, and
Okay, sir.
we'll see you tomorrow, same time. Okay.
Okay, sir.
Bye.
Thank you, sir.
Tomorrow, let's
Bye,
finish
sir.
up this.